introduce our next finalist, Joseph Guidry from the Astronomy Department, who's closing out our first half of these talks. He's going to present on photographing the perilous fate of the solar system.
Stars follow a similar life cycle to humans, and this has consequences for the planets they host. At the top of this artist rendition on the right is their adulthood stage. The sun is here today, and so are most other stars that we know of, which usually host multiple planets themselves. This is a stable, peaceful time that can last for billions of years. But this stability is finite. When stars run out of fuel, they enter a midlife crisis and grow to become enormous red giants. In 5 billion years, the sun will grow so large that it will engulf Mercury, Venus, the Earth, entirely vaporizing those planets. But eventually, red giants enter retirement. The intense heat deep inside them pushes away their outer layers, leaving behind the small, dense, and hot core, a white dwarf star. I study white dwarfs. Over 40% of white dwarfs are surrounded by disks of dusty planetary rubble, like what is depicted here in the bottom right. Now, these disks are about as close to the star as the moon is to the Earth. And so if the red giant incinerated everything nearby the star, how did this debris get there? It had to come from the outer reaches of the planetary system. Planets like Jupiter and Saturn are far enough away from the sun to survive its red giant phase. And their gravity is large enough to be able to throw around smaller survivors across the planetary system, namely asteroids. If an asteroid is thrown close enough to the white dwarf, the star's gravity will shred it apart and produce the debris that we see here. I led the development of a novel technique to discover the white dwarfs that are blocked by their debris disks. We call these transiting debris systems. And my technique spurred the growth of this class from just 2 systems to over 20 over the past 6 years. When I find a transiting debris system, I take thousands of images of it. And these images aren't pretty like these artist depictions here. My stars are just a few pixels large in the images. But I can still record the star's brightness from there. And so I look for the star to dim as some of the material passes in front of it and blocks its light. Once I see that, I keep taking photographs with a telescope until it does it again, and then again. When I confirm a repeating pattern, like what we see here in the bottom left, I know how far away that debris is from the star and how rapidly it's orbiting. I've measured repeating patterns at 4 of the 6 known cases within this new class, at periods ranging from 4.5 hours to over 100 days, all in agreement with simulations of white dwarf planetary systems. And so the next time you gaze upon the stars at night, think about which chapter of their lives they may be in. Thank you.